of 1010. So this is 192.168.1.170. Make sure now if you count the number of bits, you realize it's all 32 bits. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32 bits. So hence an IP address is made out of 32 binary, 32-bit binary. Did everybody get that?
Yes, sir.
Okay, now keep all of this in mind. It's going to come and play a key role in subsequent topic when it comes to subnetting. So don't forget it now. Just keep this in your head. Or if you're writing it somewhere, keep that in mind. Now let's move on. IP addresses consist of two parts. Two parts on IP address. There's the part that identifies the network, and then the part that identifies the node. The network part is usually used to identify the number of devices or the broadcast domain in which a computer can actually send information out to, which means that when you have a group of IP address on a given computer having the same network address, it means that they can exchange information without actually going up to any other layer of the OSI model or moving into hierarchy. They can easily exchange information just among themselves. It's kind of like the way a street and address is. Let's say you have a street, and then on that street, you have a number of houses on that street. If you want to go and talk to maybe your neighbor, you only get on the street and then you move maybe some few steps or you walk some few distance and then you go to your neighbor's house. You don't have to go and cross a highway before you can get to your neighbor. So that street becomes your common channel of transmission, and that's what is termed as a network. So it means that when multiple devices have the same network address, or in the example that I just gave you, if multiple houses are on the same street, are linked by one street, it means that they can easily access each other via that main street. But the very moment you have to go to a different address which doesn't share the same street with you or with you, it means that you have to move out of that particular street that you're on, and that becomes a non-network address. Okay, so I'm just using it as an illustration, but don't give me the definition in an exam. No. In a technical explanation, a network address is used as a broadcast domain for a given network. Okay, is the domain in which two or more computers can actually talk to each other without being routed out. So the broadcast domain is usually what is represented by the network. The node parts are the addresses that can be assigned to a given device on a given network. So that's a node part. So hence you have two parts to an IP address, the network part and node part. The node parts are purely for the addressing the various computers, and the network part are used as the broadcast domain points or addresses. Okay, so these are two main parts that every computer IP address has: a network and a node part. So IP address also have been grouped into different classes. We actually have 5 main classes. And the classes are grouped into alphabets. So you have class A, class B, class C, class D, and class E. Okay? So the classes of addresses and their subnet mask determine which part of the network they belong to. So generally, the network part of an IP address, let me just go back to the network part. The network part of an IP address is basically determined by the subnet mask. So if you look at my computer, for instance, as an example, the network part of my computer here will be the 192.168.1, so 168.168.1 will be the network part. So the network part for a class C takes up the first 3 octets, and then the node part is just the last octet because it's a class C IP address. Now let's look at the classes of IP address so you guys can actually get a good illustration of it. So class A begins with 1 and ends at 126. 127 is reserved, and we'll get to that later. Class C begins from 128 and ends on 194. Now these numbers are actually, or the class of IP addresses are actually determined from the first 4 bits. So the first 4 bits will determine which class an IP address belongs to. So with this scenario here, well, let me finish that part first before we get to the. So class B begins from 128 to 192. So 191. Class C starts from 192 to 223, and then class D 224 to 239, and then finally class E, which is actually reserved for, it's just a reserve, it's never been used, starts from 240 to 254 out of the 255 that we have. So if you take this illustration, since we are using the first 4 bits to determine the class of IP address, 1, 2, 3, 4, the first 4 bits, this first 4 bits is what determines which class of IP address you belong to. So in this case, we had 192 because you had 1100, and 1100 is 192. So once you know it's a 192, you can easily tell which class it's going to belong to. The 192 belongs to a class C IP address. If I were to give you an IP address, of say 92.170.10.5. What class does this IP address belong to? The best way to do that is by changing this to binary so you can get the first 4 bits. So in binary, this will be 0, 1, 0, because you have 64 here. So if you have 64 out of 92, what do you have? You need 64 out of 92. 92 minus 64 gives you 28. So it means that this cannot come, 16 can come into play here. You can have 16 here. So you have 64 plus 16, which will give you 80. And then you need 12 more, right? So 12 more to give you 12 more means you can have 8, you can have 4, and then the rest are 0, 0. So the first 4 bit was 64 plus 16, which gave you 80. 80 falls under class A, because class A starts from 1 to 126, and 80 as well as 92 falls within this range. So that's a class A. So always the first octet and its 4 bits will determine which class of IP address you're going to belong to. Here's an example. You have, let me use 152.64.100.10. So 152, you're going to have 128 being on. So 152 minus 128, what do you have? Anybody? 152 minus 128. You have 24 left.
24.
Huh? Yeah, 24. So 64 cannot be turned on. So 64 has to be off. 32 cannot be turned on either because 32 is bigger than 24. So also 0. But 16 can be turned on because 16 is less than 24. So 16. 16 out of 24 will give you 8. So 8 can be turned on and the rest has to be turned off. So the first 4, which was 128 plus 16, 128 plus 16 is 144. 144 and 152 all falls within a class what? A class B IP address, right? Because class B is from 128 to 191. And this is 154 of 144 in terms of the 4-bit, which is less than 191. So and it's also greater than, sorry, this is, I mean, this is supposed to be less than, right? Right? 144 is less than 192. But at the same time, 144 is actually greater than 128. So it's but less than 191. So hence, it's a class B IP address. Right? Based on the, yeah, 128 and 191. That's a class B. Anyway, so that's the way it works out in terms of how you determine the various classes of IP address that we have. Now, if you notice, class A, we had it starting from 1 to 126. So it's missing 127. That's the only missing address. Now, it's missing because 127 is reserved as a loopback IP address for testing only. So let's say, for instance, you built a computer system, and you contacted IEEE either directly or indirectly via Railtel or Broadcom or Qualcomm or 3M, who are the main manufacturers of network adapters, and they gave you an Ethernet adapter interface, and you want to test to make sure that that Ethernet adapter interface is working perfectly. It can exchange information. You can use the 127 IP address to actually test it. But the loopback IP address is actually this. The loopback IP address is 127.0.0.1, and it's only used for testing purpose. It's a class. Actually, it doesn't even fall into any class at all. It doesn't fall into any class because of the fact that it's 127. It's neither in class A or class B. It's just a reserved IP address. So we say it's reserved for testing only as a loopback IP address. Okay, so how does it work? Let's take an instance. If I want to check to see to make sure that my Ethernet adapters are working perfectly, if I'm not connected to any network, I can just type ping the loopback IP address is 127.0.0.1. And if you notice, it'll be going through. Even though this IP address is not assigned to any device, I can still reach it because it's just pinging itself. So every network adapter has got a default IP address assigned to it as for testing purposes only, even if it's not connected to a network. Okay, it's the only IP address that every single compute device that has got a network adapter can use to test itself to determine whether it's actually working or not. So hence a loop back. You're just looping back to that particular interface to test to see if it's actually working perfectly. So hence reserved for testing only as a loopback IP address. Okay. Okay, so that is just reserved for loopback. And it's 127.0.0.1. The loopback is a test mechanism for most network adapters, as I mentioned. So messages sent to this address do not get delivered to a network, but instead the adapter intercepts it as a loopback message and returns them to the sending application. IP applications often use this feature to test the behavior of their network interfaces, like I pointed out. Okay, guys, so that's how it is. It just points to itself. So that's what I just went through with you guys. Class D and E have been reserved for specific purpose. Class D is usually used for multicasting. Multicasting is a mechanism that is defined for various groups of nodes and used to send IP messages to those groups other than every other node on a network in terms of broadcast. Class E addresses are reserved for only future use. So it's only class A, B, and C that are mostly widely used IP addresses. Now, class A IP addresses, when it comes to the two parts on IP addresses, we can differentiate which ones are the node part and which ones are the network part. Class A has got its first octet as a network part, and then the first three octets as the node part, which means that you can actually assign a lot more IP addresses if you're going to deal with a huge network. So if you're going to work with a huge network, it's ideal to use class A instead, class A IP address instead, because of the fact that it's the only IP class that can allocate 3 octets for just the node part. The node parts are the device that can actually be assigned IP addresses. So this means that you have 8 plus 8 plus 8, and that is what? 24. So you have 24. Since it's the bits number, you have to raise it you have to get a log of that. So actually becomes, so to actually determine the number of IP addresses you can get in the class A IP addresses for a node part, you have, so class A that has got the network and then the node part. The small ends are the node part. It means you have 8 bits, 8 bits, 8 bits, which is what? 24 bits that can be assigned. So to actually get a total number of IP addresses for this node, you say the log is 2 raised to the power 24. And that should give about 4 billion something. 4 billion, let me check for instance over here. Around 4 billion, right? So 2 raised to the power 24 is 16 billion, sorry, 16 billion. Oh yeah, so that's right, 16 million, sorry. Is 32 that give you 4 billion. So this is actually this is 16,777,216. So that's how many IP addresses you can assign, which means that if you're dealing with millions of devices that are connected to your network, ideally you should go with a class A IP addresses. Now, for the default, it's 32 because because an IP address has got 32 bits. So IP address generally, I keep going back and forth on this. So IP addresses generally have 2 raised to the power 32 bits, which will give you 4 billion. 2 raised to the power 32 is 4 billion 4294 96 296. So that's 4 billion IP addresses that IP version 4 can actually support. It can support this number of IP addresses or devices that want to talk on a network. But when it comes to its classification, class A can only support 16,700 and blah, blah, blah. When it comes to class B, 2 octets are actually represented for the network, are used for the network, and only 2 of the octets remaining are used for the node. So it means you only have 8 and 8, which will mean you have which mean you have only 16 bits to work with. So it means 2 raised to the power 16 will give you 2 raised to the power 16 is 65,536. And then if you move on to the class C, you have 3 octets used for the network and only 1 octet used for the node. So you only have 8, which is 8 bits. So it means you have 2 raised to the power 8, which gives you 2 raised to the power, 256. But since in binary representation we start from 0, it actually 2 raised to the power 7, which is 255. We count from 0. In computer, we count from 0. So it's from 0 to 7, which will give you 8. So hence the maximum value is 255. It's 255 in terms of assignable IP addresses or location-wise decimal representation. You have 255. But in practical terms, it's just, so in theoretical terms, it's 256. But in practical terms, you have 255. Okay? It depends on how the question is framed. In theoretical terms, you can allocate for class C, you have 256 allocations for IP addresses. But in actual practical terms, it's actually 255 because in computers, we start from 0. It's from 0 to 7, now which will make up 8. I hope you catch on, like what we have over here. See, it's 8 bits, 1, 2, 3, 4, 5, 6, 7, 8. But we started from 0 because in computers, 0 is also considered a value. So we start from 0, 1, 2, 3, 4, 5, 6, 7. That's what we got, the 255. So in practical term, it's 255, but in theoretical term, it will be 2 raised to the power 1, 2, 3, all the way to 2 raised to the power 8. So I hope you guys got that. Oops. Okay, so now that you've gotten these things down pat, I'm guessing we can move on. So the network part, it's what determines the subnet mask, which is also going to be a representation of the broadcast domain in which multiple devices can actually operate or send information within or on. So with that, we can easily identify the various subnet masks or the network addresses for all the 3 classes that we have.